What if a video game accidentally told you the secret of the universe? Think about it. Game developers create worlds with rules-limited graphics and clever shortcuts. They add fog to hide low detail areas. Use textures that only look good from a certain distance. They cap the speed of light in the game engine because calculating infinite speed would crash the system. Now look at our universe. Speed of light is capped at 670 million miles per hour. Why? Why would the universe need a speed limit? In a video game, the answer is obvious. Processing power. Game can only calculate so much per frame. Our universe has a pixel too. It is called the Planck length. Nothing can be smaller. That is exactly like the pixels on your screen. And here is the strangest part. Video games have bugs. Glitches where objects clip through walls or characters float in the air. Scientists have found similar glitches in quantum physics. Particles pop in and out of existence. Information seems to disappear into black holes. Are these bugs in the simulation, or are video games accidentally teaching us how our own reality works? Today we uncover the shocking parallels between your favorite games and the simulation hypothesis. If you're ready to uncover the truth behind our simulated universe, hit like and subscribe to join us on a journey through the mysteries of simulation theory. Let's get started. Simulation theory says our universe is a digital creation. But how would we know? One way is to look at the video games we build. They are smaller, simpler versions of the same idea. Every game has limits. Draw distance is how far the game renders details. Beyond that point, you see a blurry, low-resolution version of the world. Our universe has a cosmic draw distance. It is called the cosmic horizon. We cannot see anything beyond about 46 billion light years because light has not had time to reach us since the Big Bang. That is exactly like a render distance in a game. The universe only shows you what is within range. Everything beyond that is not rendered. Another parallel is texture resolution. In video games, objects look detailed up close but blurry from far away. In our universe, quantum mechanics says the same thing. You cannot know both the position and speed of a particle with perfect accuracy. The universe blurs reality at small scales, exactly like a game blurs textures at large distances. Then there's the concept of level of detail. Games use simpler models for objects far away to save processing power. Our universe might do the same thing. The cosmic microwave background is smooth and uniform, like a low-resolution skybox. But when you look close, galaxies and stars appear in high detail. This is level of detail optimization built into reality. Why is this relevant now? Because we are building games that look more like our universe every year. Latest game engines use ray tracing, which simulates light exactly as it behaves in physics. They use procedural generation, which creates infinite worlds from simple mathematical seeds. These are not just game features. It might be windows into the code of our own existence. In the next section, we will explore the most mind-blowing parallels that game developers accidentally discovered. Here is the real challenge that makes this topic so fascinating. Video games keep stumbling into the same solutions that nature uses. Take the game Minecraft. It uses chunks. The world is divided into 16 by 16 blocks. The game only loads the chunks near the player. Chunks far away are stored as data but not rendered. Our universe might use chunks too. Physicists have proposed that space-time itself could be made of discrete chunks. They call it the holographic principle. Information is stored on a two-dimensional surface like pixels on a screen. The three-dimensional world we experience is a projection. That is exactly how a game stores a 3D world on a 2D computer screen. Now consider the game No Man's Sky. It uses procedural generation. The game creates an entire universe of 18 quintillion planets from a single mathematical seed. That is incredibly efficient. Our universe might work the same way. Physicists have discovered that the laws of physics can be derived from simple mathematical rules. The fine structure constant, the speed of light, the mass of an electron. These could be parameters in the universe's source code. Change one parameter and you get a completely different universe. That is exactly how No Man's Sky generates different planets from different seeds. Then there is the problem of glitches. Every gamer knows the feeling of falling through the floor or seeing a character T-pose. Those are rendering errors. Our universe has quantum fluctuations. Particles appear out of nowhere and disappear. This looks exactly like rendering glitches. A particle pops into existence where it should not be. The system corrects the error and the particle vanishes. The challenge is this. If our universe is a simulation, then we should be able to find more glitches. And we have. The quantum eraser experiment shows that reality changes based on whether someone is watching. That is a performance optimization. Double slit experiment shows that unobserved particles exist in multiple places at once. That is data compression. The evidence is stacking up. But most scientists refuse to look because the conclusion is too strange. We will look anyway. Let me take you inside the mind of a game developer who accidentally discovered the secrets of the universe. Imagine you are coding a massive open-world game. You want the world to feel infinite, but your computer has limited memory. What do? You use procedural generation. You write a function that takes coordinates as input and outputs terrain features. Same coordinates always produce the same output. This means you never have to store the whole world. You just store the seed and the function. Now imagine you are a physicist looking at our universe. Notice that the laws of physics are consistent everywhere. The same equations produce the same results on Earth and in distant galaxies. That is exactly what you would expect from a procedural universe. Laws are the function, the seed is hidden. Now think about rendering. In a game, the engine does not waste resources on things the player cannot see. If a tree falls in a video game and no player is nearby, does it make a sound? No. The game does not even calculate the tree falling because no one would see it. In our universe, quantum mechanics says, if a tree falls and no one is watching it, does not exist in a definite state. It exists as a wave of probabilities. That is the same thing. Simulation only collapses the wave function into a definite reality when a conscious observer looks. This is not a coincidence. It is a design pattern. Game developers and universe developers face the same constraints. Limited processing power, finite memory, the need for optimization. Now here is the existential part. You are playing a game right now. The game is called reality. Your consciousness is the camera. Simulation renders whatever you look at in high detail. Everything outside your attention is running in low resolution or not at all. Think about your peripheral vision. It is blurry and colorless. That is a rendering shortcut. Your brain fills in the details. The simulation does not waste pixels on the edges of your vision because you are not looking there. This is efficient. This is elegant. This is exactly how a simulation would work. And here is the cliffhanger. Video games are small copies of our simulated reality. Then what happens when we create a game so realistic that the characters inside become conscious? Would they start asking the same questions we are asking now? And would they ever find out that we are their gods? Here is the most powerful argument that video games accidentally reveal the nature of reality. In 2016, a team of physicists simulated a small part of the universe on a supercomputer. They used a technique called lattice quantum chromodynamics. They divided space into a grid of points just like pixels in a game. The simulation worked. It accurately predicted the behavior of subatomic particles. They asked a shocking question. How would the simulated particles inside the computer know if they were in a simulation? They would look for the grid, they would look for the edges, they would look for the pixel size. Now look at our universe. Physicists have found a minimum possible length. It is called the Planck length, about 1.6 times 10 to the minus 35 meters. Nothing can be smaller. That is exactly like the pixel size in a simulation. Below that scale, space and time might not exist. We also have a maximum speed, the speed of light. That is like the maximum processing speed of the simulation. Information cannot travel faster than light because the simulation cannot calculate faster than its clock speed. Then there is the cosmic microwave background radiation. It is the afterglow of the Big Bang, but it could also be the noise floor of the simulation. Every computer has background noise from electrical fluctuations. Cosmic microwave background is incredibly uniform, but has tiny ripples. Those ripples could be the simulation's equivalent of processor noise. In 2017, a philosopher named Nick Bostrom published a paper arguing that if any civilization reaches a post-human stage, they will almost certainly run many simulations of their ancestors. If that is true, then the number of simulated minds vastly outnumbers base reality minds. Therefore, we are almost certainly in a simulation. Video games are the early prototypes of those ancestor simulations. We are building the very technology that will one day trap conscious beings inside virtual worlds. And they will look back at our primitive games and wonder. They will see Skyrim's glitches and Minecraft's chunks and No Man's Sky procedural generation. They will realize that their universe has the same features, the same optimizations, the same limits, and they will know the truth. Reality was built by someone exactly like them, a gamer who learned to code, a developer who learned to create worlds. The circle is complete. We are the programmers and the programmed. Let us bring everything together. Video games and our universe share the same design patterns. The speed of light is a processing limit. The Planck length is a pixel size. The cosmic horizon is a render distance. Quantum uncertainty is level of detail optimization. The double-slit experiment shows that unobserved reality exists as compressed data. The quantum eraser shows that observation collapses that data into rendered reality. Procedural generation explains why the laws of physics are consistent everywhere from a simple set of rules. Glitches in quantum mechanics look exactly like bugs in a game engine. We are building simulations that look more like our universe every single day. And one day those simulations may contain conscious beings who will look at their sky and wonder the same things we wonder. This does not prove we are in a simulation, but it proves that simulation is possible. It proves that simulations are inevitable. It proves that if simulations are possible and inevitable, then the probability that we are in base reality is almost zero. The next time you play a video game, pay attention. You might be looking at a simplified mirror of your own existence. You might be watching your creators watch their creators. The mystery runs deep, and that is beautiful. We get to be the gamers who ask the question, and maybe one day we get to be the developers who answer it. What video game feels the most like our reality to you? Is it Minecraft with its chunks or No Man's Sky with its procedural generation? Share your pick in the comments below. Also, watch our video on the simulation argument, which explains the mathematics behind why we are almost certainly in a simulation. It will change how you see everything. If you enjoyed this exploration of simulation theory, don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss an upload. If you're ready for more interesting content on the simulation theory, make sure to check out our other videos. Thank you for watching.